Let's now have a look at the subjects treated by each OG of the first call. OG1 deals with the means that allow development of robot controller software. Robot developers implement software specific to the specific target application. To allow reuse of modules across applications, their code need to rely on consistent data types, a standard application programming interface. Also, as space robots operate remotely, they need standard means for remote monitoring and control, and for dealing with failure detection, isolation and recovery. Robot software is made of several tasks, hence a middleware is needed to coordinate these tasks. Robot control software also requires strict real-time behavior, access to the robot hardware and communication and data storage means. All this maintaining the highest reliability, availability, maintainability and safety quality required by space applications. OG1 will also need to respect the fact that space hardware varies depending on the vendor chosen. The autonomy framework sits at the heart of the robotic system and is responsible for making decisions and the necessary planning to execute those decisions in alignment with mission objectives and goals. The AF will adopt a three-tiered hierarchical architecture: functional, executive, and deliberative layers. The functional layer is therefore responsible for the following functions. The executive layer is the interface between the other two layers. It receives the plans from the deliberative layer in the form of task trees, or sequences of actions to be completed. It does not possess any planning ability itself, it's purely reactive, but coordinates and controls the tasks to be undertaken by the functional layer. The executive layer has the following functions. The deliberative or decision layer takes decisions based upon input from the sensors, fused by the data fusion framework, in alignment with mission goals and objectives. It's therefore event and goal-driven. It may also be discriminatory, asking particular sensors for particular slices of information in order to best formulate its decisions and tasks to be undertaken. The deliberative layer has the following functions. The diagram shows the flow of information inside the autonomy framework, and also the interface points between the autonomy framework and the other operational grants. This OG satisfies the needs of perception and localization for both planetary exploration and orbital systems. Data fusion is necessary to achieve a satisfactory level of performance and robustness that no single sensor would be able to provide. This OG shall consist in developing a software framework designed for embedded systems and implementing data fusion techniques for various sensors. Beyond performance and robustness, data fusion will allow to acquire a global knowledge of the environment. The inputs will come from the different sensors involved in the perception process. The processing of these data through the CDFF shall result in the vehicle's localization state and models of the environment. The Common Data Fusion Framework, or CDFF, to be developed includes the functionalities of perception and navigation applicable to robotic systems in both orbital and planetary tracks. The perception functionalities include the conversion, merging and fusion of data from the sensors, detection and tracking of features and objects, construction and characterization of 3D maps. The navigation functionality provides the geometrical and dynamic state of the robot through a process of estimation that includes several sensors in the rover. Navigation function must also consider and take advantage of the presence of other rovers. In the orbital track, the targeted applications are rendezvous, inspection, capture, docking and satellite servicing. The information produced by the CDFF is required for situation assessment, motion planning and motion control. The CDFF main tasks consist in For planetary scenarios, the CDFF targets autonomous science, long-range traverse and rendezvous with other planetary assets. Its main tasks include the inspection sensor suite provides for all sensors of the robotic system. The sensor suite is composed of two types of sensors: proprioceptive sensors, which are responsible for measuring the vehicle position, attitude and dynamics while an inspection task is executed. Exteroceptive sensors are used to investigate and thus acknowledge the operational environment. The raw data are pre-processed and sent, through the means of the Robot Control Operating System, RCOS, to the Common Data Fusion Framework. The Common Data Fusion Framework, upon a specific request, provides the autonomy level with data, through RCOS. The proprioceptive sensors can interface directly with the autonomy level. The driver for this OG is the desire for a standardized form of an interface allowing the coupling of spacecraft modules. A standard interface in this context is defined as a combination of devices that allow to couple active payload modules or APM, to a manipulator, among themselves and to spacecraft. It shall allow transferring of mechanical loads, electrical signals and data as well as thermal flux between the coupled modules. APMs are containers with integrated subsystem or payload components, which can be used to fulfill a certain task. Additionally, a servicing robot can communicate with module attached through its manipulator due to the data transfer capability of the interface. The standard interface may be realized in an integrated form, where mechanical, thermal, electrical, data connections are combined, or a separated form. In any case, the standard interface shall allow building up large clusters of modules. The interfaces for modular-compatible spacecraft for this OG should be designed to a few specific criteria, in order to use it for various applications in space, as listed on this slide. While there are some general functionalities that the modular interfaces will be expected to demonstrate, there are also expected functionalities specific to the type of transfer that will be enabled: mechanical, electrical, data and thermal.